That's weird. People showing up now. Cool.
With the over. So I shouldn't be know it. And then post the videos of the lectures, so I should be fine. But the fact that you took it to this and I'm not there pissed me off.
Huh.
Anyway, I need to dry these pants longer so they're not wet. Week after I wash them.
Mute everybody. There you go, mutated. So as soon as Mr. Archer shows up on the call, he will lead you through the lab exercise, and I'll be rendering the lesson recording and actually fix some broken parts of the syllabus. So if you try to access Lab4.1, that I think works, but exercise 4.1 is not working correctly, and the syllabus doesn't go to the notebook correctly. And I can fix that as soon as I can hand off the lab to your TA. Who is not showing up? Okay. Well, I know it's working because you're all here. All right, we'll do it the hard way. I'll go ahead and lead the lab. Let me turn on my screen sharing and get to the lab part. And naturally the server is defunct. Okay, so I'm cheating. The way you'll get to it, it will be through Blackboard. Go to instructor's notes. Actually, go to the correct one though. Yeah, no, there's an error. Go to the instructor notes. Go to data structures. Down at the bottom, And you could either access it this way and then download by right click, save link as, or you can actually directly right click here, right click, save link as, and good to go. So I'm now actually on the server, and we will do lab 4.1 data structures. Let me take a quick look to see. It's really not here. Must have had something go on. And I'll get rid of that. So here is our lab, and I don't do the dark mode, so so be it. So I would suggest that you change your first name and last name at the beginning, and then let's just go down through the lab. So the first part of our lab is to introduce the data structure type of a list. And these contents are exactly from the lesson. And we're given a script that's already been prepared for us, so we can execute it, and we could change things, make that 7655, and so we would expect that to become a 7655 right there. Rerun it, sure enough. So let me check the chat. As you can tell, I don't do the labs very often. Okay, so I got the chat window in my lower right-hand corner so I can see any questions that come up. So there's the list that's from the lab. This is called slicing a list. If we want to make a list that's a subset of the original list, we would give it a name, and we take the original list. In this case, it's starting at element 3, it's ending at element 6. So the third element is 0, 1, 2, 3. So it'll pick up the 9, 4, 5, and it won't do the 6th thing because that's how the slices are designed in Python. So it gets us our sublist of 9, 13, and 66. There is the summation function, which gives us the ability to add up the contents of a list if it's defined. And so if we do sum of sublist, it takes the number 9, adds it to 13, adds it to 66, and returns an 88. So lists don't necessarily have to be numeric. Another type of list could be a collection of strings. And if it's a collection of strings, I have no idea what summation will do, but how do we explore that? We can create a list of strings. Make 4 strings. So somebody pick their favorite word and type it in the chat box. Food, banana, macaroni. I just need one more. Someone give me the 4th thing. Sword, okay. I don't need any more words. So we have food. Banana. Macaroni. Oh, I like that one, Dwight. Jubile. And we'll get the sword there. So there is my list of strings. If I execute the cell, we do not get an error message. So let's just go ahead and print. And it regurgitates back food, banana, macaroni, jubilee, and sword. Now, the whole point of doing that is I want to see what the sum function does. My string sum. So as part of our problem solving development, prior to executing that, let's try to anticipate the possible outcomes. Okay, so one possible outcome is the pink rectangle of encouragement. It'll tell us that something is not right. And that's quite likely. The other possible outcome is the equivalent of sum for strings is concatenation. It might concatenate all those things and give us a single output: food, banana, macaroni, jubilee, and sword. Now, my gut feeling is summation for strings is not defined. But since I don't know, how do I find out? Thank you, Catherine. That is correct. Just go ahead and execute it because it's not like the computer's going to blow up. And sure enough, unsupported operand type for plus, integer, and strings. It doesn't know how to operate on sum. And since that's weird enough, let's go ahead and so here's a sum function in Python. Let's see what sum does let us do. So it tells us what to sum. And if we want to start anywhere other than 0, we can. A is a list. It adds up to all the numbers in the list. Yeah, it can't handle. Yeah, I'm not going to sign up. It can't, it does not have the ability to automatically concatenate. That's kind of a shame. Maybe they'll fix that in a future rendition. That's weird how that went all dark. So let's continue and let's take a look at tuples and dictionaries. So remember in the lesson, tuples is just a collection of things enclosed in roundy brackets. And a dictionary is in curly brackets, and the dictionaries are special in that there's a key and a value. So here's our tuple called my tuple name, and it contains the months of the year: January, February, March, April, May. We can print it and it comes right back to us. We can see if we can access individual elements. So tuple objects not callable. We'll see if the elements actually have an index feature. You can pull individual elements by their position indicator. So element 0 is Jan, element 1 is Feb, element 2 is March, and so on. So let me leave a notation. Tuple. Oh, this was really stupid because I'm actually butchering the copy of the worksheet that you guys are supposed to get. Let me quickly see if I can recover from what is potentially a monumental screw up. save as, cancel that. Oh, I broke that one, so let's fix that. Cut that out. There we go. So that I have repaired the original lab one. I'll go back to my working copy. So we were at tuples. We can also look at dictionaries, my pet's name and mass, and we can see the two dictionaries. And let's see how we access MYPET. How we access an individual element. I think we go by the key, so DUSTY. My pet's name and mass is not defined. And since we're getting lost, we can just go here and dictionary in it's the get method, my bad. So we use get accessing keys. Returns the value for the given key. Okay, so we use the get method. .get, and we want to get Dusty, and I'm not sure if we have to enclose the keys in quotes or not, but how do we find out? We do what Catherine told us to do the last time I asked the same question. And it returns the value of the key. So let's see what happens if we don't put the quotes. That probably will fail. Yeah, Dusty is not defined. We have to use the key name. And that's how to access parts of a dictionary. We can also play it with the other one. Copy that, change the name. That also works. And we'll see if this one can handle a key that's not closed in strings, and we get the same error, which makes sense. So in this case, the keys are treated as what kind of data type? The keys themselves, just the keys. They're either integers, floats, or the things you tie your shoes with. Catherine, I agree with you. I think it's a string. There's a comment that says it would have worked if I had spelled things correctly. Let's test that conjecture. Sure enough. That's actually good to know. Thanks, DJ. Moving on to tuples. So we have a tuple, which is going to contain the months of the year. And then we will go ahead and access the contents of the tuple. Then we'll do the pets' names and masses and access them in some different fashions. So let's just split the cell up a bit. We do one thing at a time. Use our split cell, split it again. So you might find cell splitting is a really handy thing from time to time when stuff starts breaking. do that right there. Okay, why I split the cells, I can do one thing at a time. So when I run the tuples, we've just created a tuple called my tuple name. If we want to find the fifth element of my tuple name, we can do that. We can even go fancy. Remember the never mind, I'll do that another day. I was going to automate getting the fifth element from my tuple name. We can look at a dictionary. We'll create the pets dictionary again, and we'll go ahead and interrogate a particular pet, in this case Aspen, and we'll recover Aspen's mass. Same thing with Mirami. We will recover her mass, and then we will change the value, and we can put it back in the dictionary. So this expression right here is going to the dictionary, my pet's names and mass, accessing the key Mirami, and assigning to the data associated with that key the value 0.01, which replaces the value that was there, and then we print it again. So the dictionary are things that are to be comparatively static but need to be changeable from time to time, whereas a tuple is used for things that are going to be indefinitely static. They're not going to change. We can alternately create the dictionary using this method, and it's the same as before. And if I clear all the outputs, let's move into nested dictionary. So a nested dictionary is defined here. The name of the dictionary is, it's 2 letters. Thank you, Catherine. FD it is. And now let's look at what's in the dictionary. Our first key is the string Quentin. Our first data object is the string Tarantino. Our second key is the string 2020. And there's the colon, which is identifying our data object. Our second data object is the list 2020 COVID-19 pandemic. And then the next key is bond. The next data item is the list, which contains the string James, the string gun, and the tuple, which contains Paris, Tokyo, and London. So this is an example of a nested dictionary. So if we create the dictionary and print it, we'll get essentially a listing of the dictionary back surrounded in curly quotes. Now let's access the dictionary part by part. If we go to our dictionary FD and we choose key 2020, that puts us in that highlighted area. And then the next thing we're taking is from the dictionary, according to key 2020, we want to find the third item in the data that's associated with the 2020 key. And so the third item 0 is 2020, item 1 is COVID, item 2 is 19, item 3 is pandemic. So we expect to get pandemic back from this interrogation. And sure enough, we do get pandemic back. Let's play that again, but we're going to now do a different sequence of operations. We'll go to our dictionary FD, search for the key bond. We found bond. And then in the data item of bond, it says find the thing associated with position 2. So James is position 0, gun is position 1, and the tuple Paris, Tokyo, London is position 2. And then we want to get the zero thing from position, excuse me, the first thing from position 2. So 0 is Paris, 1 is Tokyo. So what this interrogation sequence right there is going to return is the string Tokyo. And here are the sequence of building up the commands. So this is, if I had a need to interrogate a nested dictionary one time only, I would interrogate the first key and then work my way down until I finally get to the thing I'm looking for. And sure enough, we get Paris, which is the 0th item of the last key. That's the introduction to dictionaries, tuples, and lists. Let's go take a look at the homework that's associated with that. So your first homework assignment is manipulating a list. You're told to start with that list. And let's see what the first item says. It says, make the given list. So how would you make a list? Describe it in words. How to make this list. Assign it to a variable. That is mostly correct. So I would go ahead and hope that I can copy that. And then in this cell, I would put my list equals paste. And that should save me from having to type 22, 45, 54, 87, and so on. Then it asks us to slice the list from positions 3 to 10, including 10. Actually, let's just go do that. So you get the easiest lab ever because we'll do a couple of the homeworks right now. So I want to copy that. And paste it. Yeah, I'm working on the remote server. So if this were my homework, get rid of that thing. And so Parth said we want to assign all that to a variable. So copy. Parth, come up with a variable name. X. You are as uncreative as I am. Cap X or lowercase? No, we'll go with lowercase x. X equals. And so sure enough, we've made the list and we can verify that it exists by echoing it back to the screen. Sure enough, there's X. Yay. So the hardest part of the homework is done. Next, it says slice the list from positions. Yes, Scott, I'm aware of that. And I can fix that as soon as the lab is over. The other way to access the homework for you guys, if you want to get started now, is I will show you. I'll put a direct access into the for today only. That will get you direct access to the directory, which contains the homework, and you want to take Lab 4.1 take home as your homework, and Lab 4.1 is the lab. And so if we want to slice from position 3 to 10, somebody pick another letter of the alphabet other than X for a sublist. It says put it into a new list, NEWX. And now how do we make the slice? Y would have been my other choice too. Cap A, Adriana would be a fine choice. I chose new X. So how do I slice the positions? kind of have done the giveaway right there. So Parth says 3 to 10, including 10. So 3 comma with a dangling comma. Let's see what that'll do for us. 0, 1, 2, 3. So start at 87, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Parth, I think it's going to give us all 14, but let's find out. I think what you initially intended was something like this. Oh, it doesn't want to play, does it? And that's because I am formatting the syntax incorrectly. 3, colon. This must be integer, slices, not tuple. So he said 3 to 11. And I think if we do that, it will actually work. So the colon is the delimiter, start, finish. So 3 colon to 11 gets the 87. So that's 3, 4, 5, 6, 7, 8, 9, 10. It ends at 19. Corbin says, wouldn't it be 2 to 9? Position 0 is right here. Position 1 is right there. Position 2 is 54. If we did 2 to 9, we get this collection, which I guess is arguably position 3, 4, 5, 6, 7, 8, 9. We'd have to go to 10 to get the 11. That's kind of going to be a nuisance for y'all routinely, is position and index. So position 0, 1, 2, index 1, 2, 3, depending on the context. For this particular homework, you have plenty of control. So it says print the new list. How would we print the new list? We'll go with what we have right now. We print in whatever the list name is. So new X. And slice the new list from 3 to 7 and put the slice into another list. So even newer X. Let's go ahead and get positions 3, 4, 5, 6, 7, 8, 10. Okay, so that looks fine to me. And we want to slice the new list. So NEWX. So we want to get positions 3 from new X, which using Corbin's logic would start at 2. And we want to get the 7th thing. So we would end at 7. And that's including the 7th thing. And we'll put the slice into the even newer X. And then we will print even newer X. So let's go ahead and run that cell. Oh my, what did I do wrong? Okay, I forgot the underscore. We'll try to fix that. We still have a problem. Take a look at the print the new list. Yeah, I did. Thank you, Colin. That is correct. You notice that this square bracket is unpopulated. This cell has not been executed. So once I execute the cell and then the next cell, everybody's happy. Now let's find the sum of the another new list. So the sum is 369. The length, how do I find the length? Why are we printing from 2 instead of 3? I'm choosing to use the positions as the cardinal numbers. That's my choice. I've chosen that. So that is item number 1, item number 2, item number 3, item number 4. I suggest that you get in the habit of thinking of that as position 0, 1, 2, 3, but it's doesn't really, it matters because you get different numbers out, but it doesn't really matter as long as you're consistent with yourself. So that's why I chose the 2. So let's go ahead and get the length of the list. How do I get how long it is? Well, I'll let you all think about that. I'll get the second part of this script complete. Thank you. Terrible English, I will admit, but there's the even newer X, and it will execute. It'll run the length function, assuming we don't get any errors. It tells us that there's 1, 2, 3, 4, 5 things in it. So as a homework assignment, that should be pretty easy to do. Let's look at the second one. So the second one, we have a dictionary, and we're told what the dictionary looks like. In fact, the person who created this lab, me, was very kind and even had the delimiters in the correct structure. And so you would create the dictionary, give it a name, and use the curly bracket method. And then using the keys and the indices, navigate your way to hello. So I will copy that, and whoever wants to play along can tell me what to type here. Okay, Jackson, that's a lot of typing, but A, B, E, T, T, E, R, V, A, R, I, A, B, L, E. Okay, so I've typed a better variable in X. Anything else? That's going to be the name of the dictionary. Now, how do I assign the contents to the dictionary? Equal sign, thank you. And I've already copied the contents into my clipboard, so now all I have to do is simply paste it. That should build our dictionary. How do we tell if we successfully built the dictionary? We can print it. So I'm printing a better variable than X. And it returns it back to me. And if I was really anal here, I would also print what type it is. And what we should get back from that is a type of DICT. Sure enough, it's a dictionary class. All right, it says, let's find our way to the object hello. I would suggest instead of getting fancy, try the following. Start with the dictionary name and let's just figure out what key we're going to use to get to hello. Of course, I got to put it right. So if we go to the K1 key, we get 1, 2, 3, tricky, blah, 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 back. So this is position 0, 1, 2, 3. So let's see what happens if we take the third thing back. So now we're at another dictionary, which has a key of tricky, and then, oh man, exception. So we'll try that. And that one, we're at position 0, 1, 2, 3. So you see what I'm doing here? I just build up for doing these pedagogical manipulations. It's a whole lot easier to just build up stuff one at a time. Now we're to the dictionary that has the key named target. We're getting close there. And hello is which item? Item 0, 1, 2, or 3. Dun, dun, dun. That's supposed to be the Jeopardy tune. Landon says it's 3. Okay, this is for all the bragging rights this minute. Ta-da! It says hello. Now, for practical applications of dictionary, you're not going to be necessarily dealing on this way, but you could certainly automate this search when we get to repetitive structures and have it work its way through a dictionary to find things. That's pretty much how Amazon finds your orders when you buy something from them. Probably a little more sophisticated. There's not a mechanical Turk sitting on the other end that's typing these things one at a time, but it's just working its way through a dictionary, which is another name for a database inside whatever their server is. Okay, are there any questions? This was a quick lab because it was meant to be a quick lab. So I will close that. And actually, we'll delete it so that you have to do it yourselves. Bye. And I will take out my working one. May I stay after class? Sure, Milton. I don't know why you want to, but let me delete this one. If we followed along, can we turn that in, assuming you saved it on your machine, because I just deleted the working copy and the one I was using. Sure. But remember to change it to your name and your R number and all that good stuff. Okay, if there's no further questions, I'm going to go ahead and wish you all a good day. It's supposed to, the weather is supposed to get uglier. The weather's supposed to get uglier this afternoon. So if you don't have afternoon classes, get to someplace warm and comfortable. If you do, you're as hosed as the rest of us. Have a great day, everyone. I will see you on Friday. And let me turn off the recorder.